G'day, Dave Galt here. I thought I'd create a video showing the finer points of processing a an observation that is a one star of a double star. So I will share my screen. Share. Okay, so here's a observation by Kirk Bender and Richard Nolvenius of an occultation. I'll drag the prediction over to here. Floirac, the target star was 12.2, asteroid 14.5, mag drop expected 2.4, which is equivalent drop of 89%. Similar drops in red, and it crossed California. So Richard and Kirk got lucky and observed an occultation. Here's their light curves. I'll talk. So if you recall, the expected drop. If you forget, over here is a summary of the expected mag drop and equivalent percentages. So as you can see, both Kirk and Richard observed drops that were significantly less than expected. This is due to a one component of a double star, meaning one star was occulted, but the other star remained in view. Helpfully, during the processing, Kirk used Pyote, and Pyote reported a percentage mag drop of 43%. What does that mean? I've summarized that. Oh, hang on, I pressed the wrong button. I've summarized in this little sketch here. So at least as far as Kirk is concerned, the observed drop was 43%. The expected drop was 89%. So the resulting drop from the unobserved star is 46%. So that's one way to do it. To determine the levels is to use Pyote and just simply determine it. If in the event of we don't have a summary from Pyote, we can get rid of that, I think. We can use the Occult light curve viewer, which will pop up on my other window over here. So I'll just drag it back to here. Click on here and back on here. Helpfully, Kirk submitted his light curve straight away, and it's in the database. And that's the number that has been applied to this particular light curve. So all we need to do is type in 15,169 to get the light curve. So what if in the absence of a Pyote determination of the drop, we can simply estimate it by right-click on an approximate area that would determine the mean of the full light level. Is that about right? I suppose it is. And then wherever you mouse over here will give you so 43%. Well, that's not too bad. We'll drink to that. You can see at the end of that a cursor detail 42, 43, somewhere around there. So we'll go with the number that Pyote spat out, but if you don't have that, you can always determine determine the drop by this method. I hope that's clear. So I'll get that out of the way. But before we go that far, we have to deal with something. There's the sky plane plot, and the message here is, with errors this large, you shouldn't try to fit an ellipse at all, regardless of what the shape model looks like, because anything could go. So Alt M gets rid of the model, so we don't want to mess with that for the moment. With errors this large, all you can do is turn on the used assumed diameter checkbox, which automatically turns on circular. And the assumed diameter is 9.1 kilometers, plus or minus 0.6. And we simply click the Find Best Fit button a couple of times. And we've now fitted the assumed diameter. Now, you have to be careful. What we might do is we might zoom out a bit. With errors this large, are we 100% certain that the assumed diameter circle can be fitted to this side of the observations? So to check, simply one of them, or both of them, put a negative sign there. That will force the assumed diameter circle to the south. And then we click the Find Best Fit button several times. Now, we're going to zoom in a bit more. Now, as far as the reappearances, the green is always reappearances, as spelled out down here. As far as the reappearances is concerned, either north or south fit would be valid. However, the disappearance, Kirk's disappearance, is outside the assumed diameter circle. So by a whisker, the southern fitting is invalid. So you have to be careful with errors this large. So you need to check. If Kirk's observation was the end of the uncertainty was indeed outside there, it means either the north and the south is valid, so you've got no alternative but to leave the center XY between the two chords, because north and south is indeterminate. However, in this case, as we explained, we can quite justifiably apply the northern fit to the chords. Now, as we discussed earlier, this is the drops were less than predicted, which means we need to report that that there's only one star of a double involved. Now, in the quality setting, we'll do this before we forget, is to, unfortunately, there's too much uncertainty for astrometry to be used, but we can report this observations to the Journal of Double Star Observations, and in turn this will make its way into the Washington Double Star Catalogue. So it's an important observation, and that quality setting does all that. But we need to work out the offsets. It's a simple thing for both observers. We click the companion second star, and doing so, replace, yes. Doing so will bring up the double star solution window. Come on down here, yes, I like it down here. Okay, so where's that? So because the observed star dropped 43%, in this instance, the mnemonic that I use, or the sentence that I use to determine which value goes in here, is the occulted star is the main star. So in this particular case, the occulted star is 43. The other star is, where's my little sketch, desktop, mag drop. There we go. If you remember correctly, put that over there, get rid of that. So the occulted star was 43%. The expected drop was 89%. So the balance is 46%. So we type in the occulted star is the main star, 43, and the balance is 46. And that's all you need to do, along as well as this quality setting, to finish this, at least as far as double stars is concerned. We can get rid of that. So we'll save it. Doing so will determine that the one star is magnitude 13, the other star is 12.9. If you go into solutions and list the double star solutions, which you've just done, here it is over here. You'll notice that there's the separation has got a greater than sign to the actual separation in milliarc seconds. So it's greater than 1.8 milliarc seconds, and the position angle is 17.9 degrees. So that's what will be reported to the JDSO and the Washington Star Catalogue. So one more thing to do is to deal with the shape models. So Control M brings up the shape models, and again, with errors this large, there's nothing to determine except to fit them not constrained, both. You can't even determine that that's modeled wrong. So not constrained. So that's the observation done and dusted. Now, we've determined that, or Pyote has determined that the drop was 43%. Now, with a light level that large, there is the case for setting the values at 50-50, meaning both stars would be, well, let's do that, 50. Equal brightness stars, which means both stars will be magnitude 13. But we may as well use the accuracy of Pi. Why not? And we've got the shape models done, and so that's about it. Hope this is helpful. I'll stop share my screen and get rid of that and stop the recording somewhere. Stop share and stop the recording.